Okay, so in this video we're going to take a look at finding the exact equation of a polynomial when given some information. So we're going to take a look at two problems. The first one just tells us about a problem here and then gives another coordinate point. The other one we're going to look at is from a graph and how we can get the exact equation from a graph. They're both going to be very similar to each other. So looking at the first one, if I have three x-intercepts right here that are given to me, each x-intercept is going to give me a factor. So if I have negative 3, 0, that means my factor is going to be x plus 3. Because using zero product property with that, if I would set that equal to 0 and solve it, I would get x equals a negative 3. So that's how I get that factor from that root. My next factor then, from that root, or from that x-intercept, is going to be x minus 2. And my last one is going to be x minus 5. So now I have all of those. So I have y equals this, but in order to make sure that it passes through this point, I need to make sure my stretch factor is correct. So I have to have an a value out front. I now use my coordinate point, and I substitute it in. So 56 was the y value from that, equals whatever my stretch factor is, and now my x values, again, are 1. So 1 plus 3, 1 minus 2, and 1 minus 5. Now I only have one variable left. It's just my a value. So all I do is simplify. So 56 equals a times 4 times negative 1 times negative 4. Which means 56 equals positive 16a. So negative 1 times negative 4 gives me positive, and times the 4. From there, I now go through and just solve for a by dividing. There's my giant 1. So a equals 56 divided by 16. I can either reduce that fraction, so I could take an 8 out of both and get 7 over 2. Or it is a 3.5 as a decimal. So now when I have my equation, what I have in red, instead of now writing this a value there, I'm going to now replace that a value with 3.5. And there is my exact equation. Taking a look at the second example, I have an x-intercept right here, and I have an x-intercept right here. That's giving me two factors. The factor from this one right here is going to be x plus 2. The factor from this one is going to be x minus 1. Now, there's something special going on with this factor because of the fact that it bounces. It does not go through that x-axis at negative 2. Since it bounces, I know that that factor is squared, or at least has a even power to it, most likely just squared. So I'm now going to start off again with my equation of y equals some a value, x plus 2 quantity squared, times x minus 1. I need another coordinate point that is not on my x-axis. An easy one to use is my y-intercept right here, which is the point 0, 8. So now I'm going to substitute that in. 8 equals a times 0 plus 2 squared, and 0 minus 1. So simplifying that down, I'm going to get 4 times a negative 1. And that gives me a negative 4a is going to equal 8. So my a value then will equal a negative 2. Which makes sense because, as you see, the right arrow is facing down, which means I have a negative orientation. So now I rewrite my equation with my appropriate a value.